Okay, today we're going to talk about function. And what is a function? A function is a relationship that exists between two sets of members. A relationship that exists, okay, between two sets of members. In other words, we're saying members of one set is associated with members of another set. Now, an example of this, we can have a set A like this, where you've got 0, 1, 2, 3. And this is associated with another set, which is a set B. And let's say that this is 2, this is 3, we got 5, etc. 2, 3, 4, and perhaps 5. Clearly speaking, this is a set A, and you got a set B. And when we talk about members of this set is associated with members of another set, these are the input values, and this is the output values. The input goes through a function, and the function may be called fx, okay, and then it becomes the output. So if 0 is becoming 2, an example of this could be, let's say f0 is equal to 0 plus 2, which gives us 2. Got f1 could be 1 plus 2, meaning this is 3. You got f2, and this is going to become 2 plus 2, giving 4, etc. So clearly speaking, what we are looking at here is fx is equal to x plus 2. This is our function. And it's a one-to-one function in the sense that each input value has an output value. Each input value has an output value. We've seen 0 gives 2, 1 gives 3, 2 gives 4. After we undergo the function, fx is equal to x plus 2. Now this is our function, and it is written as fx is equal to x plus 2. How do we read it? So we read it as f is such that x maps to x plus 2. And to understand this further, we can illustrate this by going further into, let's say, drawing the line itself. Here is our function y is equal to fx, and this is the x values, x-axis, which is often called the domain. Okay, and this is called the range. Now, because this is x plus 2, clearly it crosses the y-axis at 2. So our line is going to look something like this, and it crosses at 2 here. So 0 gives us a value of 2, we have 0 gives us a value of 2. And from here, we understand that each value of x, 1, 2, 3, is going to have a unique value of y. Even the negative one. So, as can be seen, the diagram illustrates this even more clearly. Alright? That's a one-to-one function. And we can also have a many to one function. An example of this would be a quadratic curve. A many-to-one function, okay, is clearly a function that has input and output values as well. And to find out or understand this more clearly, we can have a function like this. This is a quadratic curve, okay? And what we see in this quadratic curve, so that this is fx, and this is x. Maybe this is y is equal to, let's say, x squared, to put it as simple as such. Okay, now for each value, you've got two values of x here. One, two. It's going to give you only one value of y. So this is basically a situation where you've got two values of x, let's say x1 and x2 after you solve the equation, and for each of these values you get one value of y here. So if you were to illustrate it from a point of view, like you've got a set here, another set here, you can have, let's say, set x and then set y, and you've got y is equal to x squared. So you can have, let's say for example like 1 and then 2, and both of these gives one value of y. So this is basically what it is all about. This is function. And now we've seen that a one-to-one function has these characteristics and features. What I also want to explain is that for a one-to-one function to exist, what's the criteria? It has to pass the horizontal line test. What I mean by this, you may get a function like this, not necessarily a straight line, it could be a curve, your x and y values. So the curve carries on. Now you can see that for each value of x, I've got a value of y, an input and output. However, for a function to be a one-to-one function, it necessarily has to pass the horizontal line test. And I'm coming to that to explain to you what I mean by this. Is that if you draw a line here, you draw another one, however many lines you draw, all these horizontal lines, the moment they cross the curve, the input value is going to give you one output value. So that's a one-to-one function. For instance, that's not a one-to-one function. That's a many-to-one function. Okay. And the values of x here, the value of x here, let's say we have got x is equal to 2 here, and finally you've got x is equal to, let's say 6, alright? And for some reason this is your function, y is equal to fx. And the values of x are limited here, from here to here. So we've got a domain. This is called the domain. So the domain of this function, domain is equal to, is basically 2 being less or equal to x, less or equal to 6. That's our domain. And what do we understand by range? Okay, so if we want to understand range, the range is all here. From that point to that point, like here. From the bottom to the top. We could have a value here, let's say for example, what is x to the square, what is 2 to the square is, let's say 4, and then what is 6 to the square is 36, so you end up 36 here. So your range for this domain, okay, which are the range or the output values, like we explained at the beginning. So from 2 to 6 we get 4 to 36, so 4 less or equal to the range fx less or equal to 36. This is how we understand what range, what domain is all about, and how do we get our range by using the domain. And also I'm going to come to the idea of the inverse of a function. Okay, what's the inverse of a function? If we take the same example, a similar example here, let's for example take this one, our function here. Let me just put this thing, fx is equal to x plus 2. And I want you to find the inverse for that function. Let's find the inverse. Find the inverse of fx, often written as f inverse of x. So, how do we find the inverse of this function? And which applies to all the other functions as well. If you want to find the inverse, you always do the same thing, the same method. I'm going to call this y is equal to x plus 2. Then you can turn this x into the subject formula. So you send the 2 here, you're going to get y minus 2 is equal to x, and therefore I have the inverse of that function is going to be equal to x minus 2. You inverse it from this thing. You inverse it from y to x. So this is your inverse. And quickly I'm just going to go over, which may be applicable here, alright, the domain and the range. It must be understood that if you take the inverse of a function, okay, then the domain of the function fx, the domain of the function, so the domain of the function is equal to the range of the inverse, of its inverse. It's the opposite, okay? It's a bit like, let's talk about this here. Suppose you've got a curve like this, and you want to find its inverse. So basically the inverse is ln y is equal to x, it's going to go like this. So this is y is equal to fx, and this one is y is equal to f inverse of x. Okay. So all the x values becomes the y values, and all the y values become the x values. So what we mean by this is that the domain, which is the values in the x-axis, for the function becomes the range, okay, for the same function on the y-axis. And similarly, we're going to say the range of the function is equal to the domain of its inverse. So that's about it for the time being. Okay, I hope this video is going to help you in trying to get an understanding of what function is all about. And I could go further by taking some examples to work with it, but we may come and explain all of that in another video. I just don't want to make it too heavy or lengthy for you. Just want you to digest this and try to understand. Maybe you can go over it again by watching the video several times until this gets well into your mind, so you understand. It's not just like you're working with functions and you're just getting your answers and you don't know what this thing is all about. It's very important to understand the mechanics behind it and what actually function is all about. Take care.